Hello friends, welcome to my YouTube channel, and today we are going to solve this integral over here, that is e to the power 2x into cos of x dx, by using the most popular method in mathematics, integration by parts. If you really want to know about the simplest methods that can be used to solve such integrals, I've added the link in the description, or you can click on the I tab button to watch out that video as well. So what integration by parts says, that integration of u into dv is simply equal to uv minus integration of v into du. Now I am assuming that you all are familiar with this integration by parts formula. So from here my u is equal to cos of x and my dv is simply equal to e to the power 2x. Now as you all know that I need to take the derivative of this u is equal to cos of x. If I take the derivative, then it becomes du is equal to minus sine of x into dx. dv is equal to e to the power 2x. To find the value of d, I need to integrate it, and when I integrate it, I am getting e is equal to e to the power 2x divided by 2. Now you just need to plug in the values of this u and this v du over here in this integration by parts formula. Now if I plug in the values and substitute the values over here, what I am getting is e to the power 2x divided by 2 is equal to cos of x plus integration of e to the power 2x divided by 2 into sine of x. Now you can see that this e to the power 2x sine of x over here is similar to e to the power 2x cos of x into dx. So that means that I need to integrate this integral again to get e to the power 2x cos of x dx. So let again assume that u is equal to sine of x, and if I take the derivative, then du becomes cos of x into dx. So from here my dv is simply equal to e to the power 2x divided by 2, and v is equal to e to the power 2x divided by 4. Now just you need to plug in the values again in this integration by part formula, and you will get this e to the power 2x divided by 2 cos of x. This is this part over here, plus e to the power 2x. This is my v, so u v, and this is my v, and this is sine of x is my v, minus integration of this v to the power 2x divided by 4 into du, this cos of x dx plus c. Now see that what we were integrating is simply e to the power 2x into cos of x dx. So if I multiply this whole equation with 4, then it becomes, you can see that this is e to the power 2x cos of x dx over 4. So if I need to multiply this both hand side with 4, so this becomes simply 4 into e to the power 2x cos of x dx equal to, this part is over here, this part over here, and e to the power 2 e to the power 2x plus e to the power 2x sine of x, here also add cos of x, minus, you can see that this becomes e to the power 2x cos of x dx. So you can see that this 4 e to the power 2x cos of x dx is same as e to the power 2x cos of x dx. Now just you need to shift this e to the power 2x cos of x to left hand side and add it with 4 e to the power 2x cos of x dx. Then it becomes 5 integration of e to the power 2x cos of x dx equal to simply e to the power 2x cos of x into 2 plus e to the power 2x into sine of x plus c. Now to find the integral of e to the power 2x cos of x, that is my m, simply I need to divide this equation by 5. So if I divide this equation by factor of 5, what I will get is e to the power 2x cos of x dx is simply equal to 2 over 5 e to the power 2x cos of x plus e to the power 2x over 5 into sine of x plus c. So this is how you solve such integral, and this is the value of this integral.